Have you ever wondered what will happen when artificial intelligence meets computational linguistics? Or how AI technology will change the world? Can you imagine a system that turns your sentences into entities and perform life-saving tasks by itself? Good morning everyone, I'm Wanyu. Today, we will discuss on how did I apply name entity recognition technology on 995 emergency text for my final year project. These are the key points of the presentation. Firstly, we will discuss the background of name entity recognition. What are the previous research on similar topic? Followed by project focus and objectives of the project, as well as the model and corpus I used for the project. The presentation will end with a discussion of future challenges and benefits of this project. Last but not least, I'll answer any questions you may have. For this presentation, I will just cover the introduction of the project, which was stated in the assignment 2. Now, we start off by providing background information on the name entity recognition technology. It is a research area under the artificial intelligence and natural language processing category. Its main focus is to identify and label the specific words in human spoken language. It then classifies those words into predefined categories called entity. Some of the examples of the entities are person's name, organizations, locations, time, medical conditions, and so on. Let's take a look at one of the examples. Let's say the sentence is, Bob falls due to low blood pressure just now. He is bleeding. The address is Street A, Block B, Level C, Unit D. There are 5 categories of entities in this sentence. Firstly, Bob. Bob is the person's name, so it's under the category of person. False. False is the action performed by the person, so it belongs to events. Low blood pressure. This is the disease name. Just now, this is the time category, which shows the time that the person falls down. Bleeding. Bleeding is the events performed by the person, so it's under the category of events. Street A, Block B, Level C, Unit D. These are the address of the person, so it's under the category of address. My project is to ask the computer to identify those entities as accurate as possible by providing large amount of training data set. In my project, I used 10 billion sentences. Some are from official database websites such as Kaggle. Others are generated by myself using OpenFST and Threads. There are several researches in the market previously. They are to implement name entity recognition model to solve different domain-specific problems. For example, extracting news articles, entities from online news platform, identifying tweet entity from Snopes data website. However, there is currently no research focusing on optimizing ambulance efficiency, or another word, healthcare. According to Clinical Negligence Team of the UK, there are more than 2,000 lives a year are being lost as a result of delayed ambulance response times. That's a huge number. Furthermore, from my research, in Singapore, our civil defense phone operators manually typing patients' information into the system, which may delay the ambulance rescue time as well. So, in view of the development of AI technology nowadays, why not implementing an AI technology system to replace those phone operators so that ambulance response time can be optimized, which in turn can save a lot of lives. So the objective of my project is to extend beyond previous research and focuses on designing and deploying new domain-specific name entity recognition techniques on emergency call text. The model I used was the bidirectional encoder representations from Transformers model, in short, BERT. BERT models were used as the pre-trained algorithm. It was selected after comparing with few other AI models, such as decision tree, support vector machine, as well as linear regression model. Since my project focuses on named entity recognition, BERT is chosen because its question and answer test advanced score is as high as 83.1 accuracy rate. The workflow of BERT is as follows. Firstly, user input a sentence to the system. Each word in the sentence goes through 3 layers of embeddings before they pass into the model. The 3 embeddings are token embeddings, sentence embeddings, and transformer positional embeddings. The model will then calculate the maximal possibilities of the meaning of the words in the sentence, and then send back to the user. The model was trained using 3 types of corpus. The first set of corpus is the SCE3 dataset. It comprises of 2017 telephone conversation, sentences, and names. The second set of corpus is the On2 Notes 5.0, which comprises of 120,000 of telephone conversations and locations. The model was also trained using biomedical corpus for its medical terms. At the end of the project, the outcome of the project is very useful. The system automatically extracts information from phone conversational text and then update the system upon receiving the call. Nearby ambulance operators and doctors will then be notified immediately with patient's location and diseases. Hopefully, it will allow the patients to be treated in the shortest period of time, which can save a lot of lives. That's the end of my presentation. Thank you. I'm ready for questions.